we are going to work on some inverse trig functions. Once again, the purpose of this video is not to teach this information again, but just to work some problems and of course explain how to arrive at the hopefully correct answer. Inverse trig functions are not that hard, but there is a catch. So a quick reminder, the catch is, so for instance, we're looking for the inverse sine of square root of 2 over 2, looking for exact values, so this is going to be one of the special angles. Anytime I'm looking for a inverse trig function in my mind, and sometimes I will write down, I'm looking for an angle. An inverse trig function is going to be an angle. So when I look at this, here's the question I ask myself. I need to go find the angle where the sine is square root of 2 over 2. So I go to the unit circle, and I go looking for an angle, a special angle where the sine is square root of 2 over 2. So here at pi over 4, 3 pi over 4. However, there is this special constraint with inverse trig functions. Now for sine and cosine, they restrict the angles to be the right half of the unit circle. And they label the angles differently than the unit circle. This is still 0, the x-axis, and this is still pi over 2. But when you go straight down, instead of 3 pi over 2, for inverse trig functions, they like to make these angles down here as negative angles. So this, the right half of this unit circle, has to be where the answers for inverse sines and inverse tangent problems. We'll do an inverse cosine problem in a minute. So now, we still ask the same question. What's the angle where the sine is square root of 2 over 2? But I have to look only in here. And of course, here at pi over 4, the sine of pi over 4 is square root of 2 over 2. And that should be the correct answer. Now the second one, this has got a twist to it and it's a little more involved. Let me actually write down this problem and give myself a little more room to work it out. So first of all, it's an inverse tangent. So just as a quick reminder, my angle has to come from this right half of the unit circle with the special angle names. But anytime, or so much of the time we do things with tangent in the unit circle, what we really have to do is we always have to remind ourselves that the tangent is the sine over the cosine. Because what I'm asking here is, I'm going to go look for an angle where the tangent, this is a special angle because it asks for an exact value. So go look on the unit circle, the right half of the unit circle, and let's go find an angle where the tangent is square root of 3 over 3. So to find tangents, we go to the unit circle and we write the sine over the cosine. So basically I need to find an angle where if I write the sine over the cosine, it's going to equal square root of 3 over 3. Now one of the things you learn when you do this very long is you sort of pick up on little key facts that can help you figure things out. One of the key facts is I notice the square root of 3 here. Now if I go to unit circle, some square roots of 3 do appear on the unit circle. For instance, looks like the sine of pi over 3 is square root of 3 over 2. There's a square root of 3. And down here at pi over 6, looks like the cosine is square root of 3 over 2. So this gives me a clue that probably the angle I'm looking for the tangent is probably one of these two, because these are the two places where a square root of 3 pops up, and I need a square root of 3 for my tangent. So let's just see what we have. Let's say, how about we will first look at if I look at pi over 3, tangent of pi over 3, just to make it clear what I'm doing here, is going to be sine of pi over 3 over cosine of pi over 3. If you look at the unit circle, sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1/2. If you simplify this complex fraction, so once again, I'm looking for an angle where the tangent is square root of 3 over 3. Well, for pi over 3, the tangent is square root of 3, so that's not the angle I'm looking for. Let's try the other one. I said the other one was pi over 6. What happens at pi over 6? Well, at pi over 6, the sine is 1/2. The cosine is square root of 3 over 2. You simplify this, and you get 1 over square root of 3. And once again, that's not what I'm looking for. So what? I know it has to be one of these special angles, so what could it be? Well, the trick is, what they've done here, I'm going to take this fraction right here, and I'm going to rationalize the denominator, which means get rid of the square root. The way we do that is we multiply top and bottom by square root of 3. So when you do that, you get square root of 3 in the top. Square root of 3 times square root of 3 is 3. So you get square root of 3 over 3. So what we're saying is 1 over square root of 3 is the same thing as square root of 3 over 3. And now I go up here and look and I say, bingo, that's what I want. So it is, in fact, this angle pi over 6. But I had to jump through these hoops because tangent can be sometimes require extra work. So we'll see if that's correct, and we get down to the tangent problem, and yes, it's pi over 6. All right, I think there's a few more on here that we need to do. Hopefully no more tangent problems where we have to jump through all those hoops. Inverse cosine negative square root of 3 over 2. All right. This is going to be an angle. Exact value, unit circle. Let's go find an angle where the cosine is negative square root of 3 over 2. I haven't talked about it yet. For inverse cosines, the angle has to be in the top half of the unit circle. Now the nice thing is it starts at 0 and it goes to pi, and it tracks exactly with the unit circle. Unlike the inverse sine inverse tangent, where sometimes you may have negative angles. So I'm looking top half unit circle. What's the angle where the cosine is negative square root of 3 over 2? Well, actually, it's over here at 5 pi over 6. Boom. That's pretty straightforward. How about inverse cosine of square root of 2 over 2? Once again, let's go to the top half of the unit circle. Let's go find an angle where the cosine of the square root of 2 over 2. Well, I know that occurs at pi over 4. So I believe the answer should be pi over 4. And it is. All right, so inverse trig functions, usually not too difficult. You just have to remember the restriction on your answer, on your angles. Now, the next series of problems can be a little more difficult. I'll say it this way. Sometimes, in certain situations, the problems are super easy, but then other times they can be pretty complicated, so you never know. What kind of problems are that? These composite functions, where you're taking the inverse cosine of the cosine, in this case 6 pi over 7. So you would think, in a logical way, you would think inverse cosine and cosine sort of do the opposite thing, so they should cancel out. And sometimes that's true. And I like to call that a shortcut, because if you give it a problem and the shortcut works, that means you just say inverse cosine and cosine cancel, the answer is 6 pi over 7, and you're done. But the question, or the issue is, that shortcut doesn't always work. So when you have these kinds of problems, the first thing you have to do is you have to determine, does the shortcut work? And if it works, then you're pretty much done. But if it does not work, then you have some extra work to do. So what's the key, whether the shortcut works or not? Well, for an inverse cosine of the cosine, if you recall, a minute ago, I explained that the angles for inverse cosines have to be between 0 and pi, top half the unit circle. For these problems, if that initial angle is in here, I call this the allowed region. I just made up that word. If 6 pi over 7 is in the allowed region, then the shortcut will work. And it's a very easy problem. So the key to all these composite function problems are you have to figure out where on the unit circle your angle is. And that will determine whether you can use your shortcut or you have to do some extra work. So where is 6 pi over 7? Hopefully, those of you who feel comfortable with fractions, you probably know pretty much right away. But in case you don't, here's what we can do. You notice here, I have a fraction with 7 in the denominator. I want to see if that's in the top half or maybe it's down here in the bottom half. What I'm going to do is I'm going to take, over here is pi, I'm going to convert it to a denominator of 7. 7 pi over 7 is the same thing as pi. So I haven't changed this value, I've just put it over the denominator of 7. So now hopefully it's very clear, where is 6 pi over 7? Well, 6 pi over 7 is less than 7 pi over 7, so my guess is 6 pi over 7 is in here someplace. Now, since it is in my allowed region, the shortcut works. And I'm done. If the shortcut works, it's a very simple problem. But the key is, does the shortcut work? And that's all we have to do. We have to take that initial angle and see if it's in a region that allows us to use the shortcut. So here's an inverse tangent of the tangent of negative pi over 19. Now remember, inverse tangents, inverse sines have to be on the right half unit circle, and at the same time they have to have angles with the correct names. So where is negative pi over 19? Well, hopefully, you know, if you want to think of it this way, negative pi over 19 really means the same thing as negative 1 over 19 times pi. You know, negative pi over 2 means negative 1/2 pi. This is a very small number. 1 over 19 is very small. So my guess is it's probably like over in here somewhere. But the key is, it's definitely in the right half of the unit circle. It's in what I call the allowed region, which means the shortcut will work and these two just cancel out. All right, so those two have been pretty easy, the first two. I assume we're going to get the one where we have to do some extra work. So let's see. The inverse sine and the sine of 9 pi over 8. Once again, inverse sine is like inverse tangent. If that initial angle is over here, then we can use a shortcut. But if not, we have to do some extra work. So let's figure out where 9 pi over 8 is. Now for now, since this is a positive angle, I'm going to go ahead and look at positive angles. So pi over 2 is here, pi is here. You notice here, my denominator is 8. Let's change this pi to have a denominator of 8. We just did this a minute ago. So in this case, pi is the same as 8 pi over 8. Now, if we're looking for 9 pi over 8, my guess is 9 pi over 8 is like maybe right in here somewhere. But the important thing to realize at first, it is definitely not in the allowed region. I was wanting my angle to be in the right half for inverse sine. So that means the shortcut does not work. I cannot simply write 9 pi over 8. So the question is, so what would the answer be? And this goes back to using, I need to go find this reference angle and then go to the same reference angle in my allowed quadrants and then choose one of those. So it's all based off reference angles. Remember, reference angle says, what's the shortest angle back to the x-axis? So here to here is my reference angle. Now if I'm sitting here at an angle of 9 pi over 8 and here is 8 pi over 8, what should this difference be here? So pi over 8 is my reference angle. So what I do with that reference angle, I go into the allowed region, the two quadrants in the allowed region, and I mark off the same reference angle. So in here, I'd mark off pi over 8, and down here, so these three all have the same reference angle. It's all pi over 8. So since I can't use this answer, it's going to be one of these two angles here. Now the question is, which one is it going to be? Well, you go back to the quadrant of your original angle. I'm in quadrant 3. We're talking about inverse tangents and tangents. What's the tangent in quadrant 3? Is it positive or negative? The tangent in quadrant 3 is positive. Therefore, if I have to choose one of these two reference angles, I want to choose the one that also gives me a positive angle. Pi over 8 is positive, negative pi over 8 is negative for the sine. So therefore, that should be the answer. Oh, I wasn't paying attention. I wrote it here. Nine pi over 8 is right here. The tangent here is, oh, sorry, I'm doing sine. My apologies, I'm so sorry. This is a sine problem. Wow, the sine in quadrant 3 is definitely negative. I'm I'm so sorry. The sine in quadrant 3 is negative. So here are my two choices. The sine in quadrant 1 is positive, the sine in quadrant 4 is negative, so therefore, yes. All right, that's why I have these answers here. So if I slip up, I'm so sorry. Hopefully you weren't too confused. So since this is a sine problem, my angle's down here, my reference angle is pi over 8. My answer is going to have to be one of these two reference angles in the first or fourth quadrant. Which one is it? I look back at my original angle, since I'm looking at inverse sine, quadrant 3, sine's negative. I have to use one of these where the sine's negative, which is negative pi over 8. All right, let's do another one. I'll try and be careful not to mess up and confuse you. Although here is a tangent one, so we'll see. Tangent of minus 13 pi over 12. Let's go find out where that angle is. And if it's not in the allowed region, then we have to use the reference angles. Maybe I'll try and do it here. I have some room. So we're talking negative angles, so let's write some negative angles here. Let's change, like let's change this one so it has the denominator of 12. Let's look at negative 13 pi over 12. So negative pi, I can write as negative 12 pi over 12. Negative 12 pi over 12 is the same thing as negative pi. Now you can see if I need to have negative 13 pi over 12, it's just going to be a little bit past negative 12 pi over 12. But the key is definitely not in the allowed region for inverse tangent. So the shortcut does not work, so now we have to use our reference angle. So this is the reference angle, the shortest angle back to the x-axis. Now you can see if I'm at minus 13 pi over 2 and minus 12 pi over that difference, that reference angle, it's just pi over 12. And now you go find that same reference angle in the regions where we're allowed to have inverse tangent answers. Now, my original angle in quadrant 2, what is the tangent at quadrant 2? The tangent at quadrant 2 is in fact negative. So when I go over here, which one of these angles is the tangent negative? And it's going to be negative pi over 12. So the answer should be negative pi over 12. All right, that's correct. All right, one more. That's good. Since I messed up on that one, let's just make sure this is pretty clear. Inverse cosine, the cosine of negative 7 pi over 9. Can I use a shortcut? Well, let's go figure out where's negative 7 pi over 9. Negative angle, so 0, negative pi. If I need a denominator of 9, let's make this negative 9 pi over 9. Now if I'm going from 0 to 9 pi over 9, from 0 to 9, halfway is 4.5. So let's just call this down here negative 4.5 pi over 9. So you can see negative 7 pi over 9 is probably right about here. Definitely not in my allowed region. In my allowed region has to be the top here. So I'm going to find the reference angle. I'm at negative 7 pi over 9. I need to get to 9 pi over 9. That's 2 pi over 9. So here are the two reference angles in the allowed region for the inverse cosine. Now for inverse cosine, this is 2 pi over 9. And this right here is actually 7 pi over 9. Now the original angle, cosine's negative. So if I were to choose these, so I need to choose one that gives me negative. Right? This gives me the cosine of this angle is negative. So I need to choose 7 pi over 9. Okay, that is correct. All right, those can be tricky. You can watch the video on that again if you need help and try and understand it.